Hey guys, starting another video. So I figured I'd go through how I handled my Programmable Logic Controller to do all the blinkers and hazards and defroster timer and everything that CPU number 2 in the RX-7 and CPU number 1 handled, basically that I needed to do. So this is the SG2 software that comes with the Programmable Logic Controller. Very easy to use. And this is the ladder that I have built for the system to handle my blinkers and my defroster timer. So it looks a little weird if you don't really, for those who don't know, ladder logic or electric schematics, weird things like that. But I was able to figure this out through a few minutes of just screwing around. It's not that crazy. So right here, I, that's an input. T, that's a timer. And then over here is that same timer again. That's the key. You have to put input to a timer, and then take a timer and go to an output. And that lets you, the output is what actually comes out. So the timer actually acts as another input. And then the world's your freaking oyster from there. You can pick and choose what you want to do what. I'll get to this part in a bit because it's kind of weird, but for the time being, we'll go over this. So I got input 1 going to timer 3, timer 3 going to output 1. So basically what it is this is my defroster timer. You can see input 1, timer 3, and then so right here it's on for 15 minutes. So 15 minutes of defogging the rear windshield. Double click on the timer itself and go right here. It's an off delay timer. So when I enable it, that's pushing the button. Use a momentary switch. Boom. You push it. Time base is in minutes. And right here it's explaining push the button, and then it's going to be on for that amount of time, and then it goes off. And you can set it for whatever you want. 14, 14 and a half, 15 minutes, whatever. Too easy. Okay. So we just did it there, and then that same thing, you have to make another input, but this time as a timer, which is down here, T. For the initial input, you use the I. So you put timer, boom, you pick which one. We used 3, so we have to use 3 again, and we have to have it on. So when it's pushed, it turns on. If you click this one, when you push it, it turns off. We don't want that. So leave it as on. Goes through, you're going to fill this out using this spot right here, A, and line, which means and. It's all based on logic. And, or, and, nor, exclusive and. And then it goes to your output, which is a Q. It's like a lot of things. You don't want to use O because it looks too similar to 0. So, out 1. So now it's too simple. Momentary switch for in. It initiates timer number 3. Timer number 3 feeds output number 1 for 15 minutes. PLC can only handle up about 7 amps, so we're only going to use this for, running the actual relay. So, because that's what the actual RX-7 system did. The timer in CPU 1, same thing. It was just a timer that ran the actual relay. And then when that 15 minutes is up, it turns off, opens the relay, it turns that off. So that's pretty easy. It's just a timer function. And now we get to our blinkers. which is going to be this entire section here from line 3 to line 9 is both our blinkers and our hazards. So we'll start with input 2. Input 2. Just like any input. Boom. Input 2. When I hit the switch to turn, it's going to send a signal to there saying, hey, input 2 is on. That goes over here to timer number 1. We use 3 back here. We're using number 1 here. All right. So as you can see, we get some different numbers in the little thing there. So let's pop it up. So timer number 1, mode 5, which is a flash timer. And you can see, as long as it's receiving signal into timer 1, so as long as the turn signal switch is up, it's going to flash on, off, on, off, on, off, on, off. And then you can determine down here how much you want it to flash. You can have it flash every 15 minutes. You can have it flash every half a second. And it's really up to you how you want to make that happen, how long you want your signal lights to flash for. So, if you want them to flash crazy fast, like a lot of cars do these days when your bulb is out, it'll make you flash really fast. If you like it like that, you can set it up like that. So time base 0.1 seconds. Your preset value, go like 0.1. Every 1/10 of a second, it's going to flash on, and then 1/10 of a second off, 1/10 of a second on again. I keep mine at about 0.4, so that you get a nice normal on, off, on, off. And then OK. Skip this middle part, and we'll go down here, input 4. That's the other direction for turning. Say this is right in 2, this is left in 4. This is going to timer number 2, and it's going to be the exact same thing. Except it's timer 2, flash timer, boom. You can do it in 100th of a second as well, and do it to 40. And the other one you can have 1/10 of a second and do it to 4. Whatever you want, if you want it to be more exact. But so those are too simple. Then down here, you got your actual outputs. So timer number 1, which was this turn signal up here, is going to output 2. Timer number 2, which is going to the other turn signal over here, is going to output number 3. Pretty simple. This part is our hazard switch. This took a sec to figure out, but I got it. So here, input number 3, same thing, no difference. On. When it gets signal, it turns on. Now it's going to the exact same circuits. This one's going to timer 1. This one's going to timer 2. It's the beauty of the PLC. You don't have to do any weird extra wires. It's all within the circuitry within the actual box. So it figures out all that crap itself. Everything's all wired together. You're just telling it which way to route it. So you can draw this nice little map up to 1, down to 2, and then right here, M01. So you're down here to M, if you look. M01, internal auxiliary relay. This was an extra relay built inside the logic controller. Using number 1, instead of on, we're doing normally not. That's what makes the difference. So, because if we didn't have it on, or if we had it on, I'll show you. If we had it on, it'll be just like these. When it gets any type of signal, it's going to automatically turn that on. And therefore is going to start running all kinds of other crap. If we turn on the hazard or the turn signal, it's going to start flashing everything. So we want to keep that as not, because we don't want it to work if it's coming this way. We don't want it to work if it gets signal from input 2, we only want it to turn on when it gets signal from input 3. So you get a NOT gate in M1, a NOT gate in number 2. So that should be the entire ladder, at least for the defogger and flashers. Now, after you build this all out, you can go up here to the simulator. And it's going to pop up all these extra windows. Now, the big ones we're going to need are right here, our input status tool right now. So it's showing you that right now there's energy going through here. Everywhere that's light green is currently powered. So, especially these NOT gates, it's powered, but we set it to not, to only work when it's not powered, which you'll see in a minute. So, let's work on input 1, our defog switch. We'll click over here, input 1, turn it on. Boom. We used a momentary switch, so it fired it all up, turned on timer 3. Timer 3 came out to input 1. Now we used a momentary switch, so it's not really going to be on this long. It'll just be a quick little. We unclick input 1, so it turns off. However, the way the logic controller works, it's still running for those 15 minutes. So it's going to keep this gate right here open and energize that relay. I'm not going to sit here for 15 minutes doing nothing, but that's how that one works. What we can see quickly, however, input 2 is supposed to be our flasher for, let's say, left. Click, and you see right here, timer 1 is flashing for 0.4 seconds. So we can go down here to timer 1, and we're running that on output 2, and it's flashing. As long as it's got signal, we turn it off, and they both stop. Input 4 is the other turn signal. We turn that on, timer 2, flashing. Go to timer 2, turn output 3, flashing. Same thing. All right, now look at this entire set between 3 and 7, because we're about to test our hazards. So we go to the hazards, and it gets energy. So that NOT gate is now overridden. Flashes timer 1 and timer 2, because we're wiring out here. Timer 1 and timer 2, and they're both flashing. And then you just turn it off, and you're not flashing anymore. And if you look up here, the defogger's still going, because we haven't messed with it yet. It's on its own internal timer. Now, this PLC, it's got 8 inputs normally. There are expansion modules, so you can make it bigger if you need to. You can do all kinds of craziness. We can stop this simulation. So there's all kinds of different stuff you have. We got inputs, expanded inputs, outputs, expanded outputs, those internal memory relays like we use here for the hazards, timers, counters if you're trying to count something, revolutions per minute, or times a fan is turned on, or how much time a fan has run or an electric motor has run. If you're looking for what time you need to replace it, you can set something up for that and place it right in the middle, as an output here, and then run the R real-time clock. Again, you could use that for a motor or a pump, so you can pull the data later and figure out, hey, how long has this been running? Should I think about replacing this now, like an electric water pump, or something like that. pattern, internal memory relays, all kinds of differential instruction stuff I haven't even gotten into yet. But there's a lot you can do with these. Like these logic controllers are made for handling systems like critical infrastructure type things like power plants and dams and weird things like that, where it's taking a lot of if-then input and figuring out what it needs to do to relieve pressure or blow off power or all kinds of weirdness. So this thing was only like $80, and I got one of the fully loaded one plus the power cable or the USB cable. So considering the price of a CPU 2 for a 94RX7, I think it was a pretty good purchase, and it can do so much, and I can always reprogram to do something else. But yeah, looking over here, there's so many different circuits, inputs, outputs, in between things that can be used for. I'm still trying to figure out because I have so many extras. But yeah, it's my phone's blowing up. Really, really useful. Beauty of it, you can sit here and you can kind of screw around with it and run the simulation up here to be able to see, hey, is my setup going to work, or is it just gonna fizzle out, go to nothing, end up being, yeah, I'm timing, but I'm not outputting. That happens too. All kinds of weird stuff can go on, but luckily you can simulate it and figure it out. It can also let you do it in hexadecimal, if you know that. As well as, you can type the whole thing out in hexadecimal. Some people know how to do that. All kinds of different ways of doing your inputs and your outputs and figuring out how to type it up. So, highly recommend it for anyone doing a major rewire and needing a way to control a bunch of different relays on one singular box where you need something extra, like a timer or a flash or a counter. So, yeah, that's about all I have. Feel free to ask any questions. Thank you. See you next time.